Hello friends, I welcome you in lecture number 2 on permutations and combinations. In previous lecture we have taken the idea about permutation and we know that permutation is an ordered arrangement of given objects. If we have n objects and we want to consider the arrangement of r objects out of given n objects without repetition, then the total number of arrangements are given by npr and the formula is n factorial divided by n minus r factorial. So whenever we are solving the problems related to permutation or whenever we are given some problem related to arrangement, then we have to check whether order is important in that arrangement or not. Whenever we have ordered arrangement, we will use permutation to count the number of arrangements or number of ordered arrangements. So whenever order matters in the count of required arrangements, we will use this formula, or equivalent formula was we have to consider product of n minus 1, n minus 2 and so on up to n minus r minus 1. If we have r here, we will subtract up to r minus 1. This is another equivalent formula. So with this in mind, we try to consider these two problems in this lecture. In first example, we have to decide the number of ways to select a first prize winner, a second prize winner and a third prize winner from 100 different people who have entered a contest. So there are 100 people who have participated in some contest and we have to decide that how many ways are there to select a first prize winner, a second prize winner and a third prize winner. That means we have to find out the number of selections of 3 persons out of 100 persons, and here it matters that order is important here because suppose we have a first prize winner, suppose some person is a first prize winner, then he or she cannot be a second prize winner or third prize winner. Therefore order is important here. So in this problem we have to consider ordered selection and we have to select 3 prize winners out of 100 total persons. So we have to find out 100 P3 and that is given by 100 times 99 into 98. If I am having 3 here, I will take care that I have 3 terms in the product. If you recall the formula of NPR, if I have to write NPR, then I have R terms in the product, n minus 1, n minus 2 up to n minus r minus 1. So if we use this formula, then we have r equal to 3, n equal to 100. So using this formula, first we will write 100 into 100 minus 1, that is 99, into 100 minus 2, that is 98. So we can remember in this way, if I have 3 here, I must have 3 terms in the product. I have to subtract 1 from each previous number. Similarly, if I have NPR, I have to write R terms in the product by subtracting 1 from its previous term. So this is the required number of ways to select a first prize winner, second prize winner and third prize winner from 100 people, and we have to write systematically. Here I have written that it matters which person wins which prize. Therefore, the number of ways to select the 3 prize winners is the number of ordered selections of 3 elements from a set of 100 elements. That is the number of 3 permutations of a set of 100 elements, and hence the number of required ways is given by 100 P3 and if you multiply these three numbers, you will have 970 200 number of ways. So whenever order is important, we will use permutations to count the number of selections or number of arrangements. Now we consider second problem, which is related to permutation. How many permutations of the letters A, B, C, D, E, F, G, H contain the string ABC? So here first we count that how many letters are there. There are 1, 2, 3, 4, 5, 6, 7 and 8 letters. But here we have to consider the permutations of these letters in such a way that those permutations contain ABC as a block. For example, another such permutation is D. Then I am writing ABC as a string, and then I am writing E, F, G, H. So this is one such arrangement which contain the string ABC. So ABC must occur as a block, and we have to count the number of such permutations. We can write another arrangement also. For example, we write D, E, F, and then we write ABC. D, E, F, ABC, and then G, H. This is another permutation which contain the string ABC. So we have to write ABC as a block. So we can consider ABC as one object. For example, suppose I denote ABC by say capital X. Suppose capital X equal to ABC. Then ABC must occur as a block. Therefore we will consider ABC as a single object. And what are the remaining objects? They are D, E, F, G, H. That is 1, 2, 3, 4 and 5 objects. So we consider ABC as a one object, and there are remaining 5 objects. That is, we are having 6 objects, and we have to find the number of permutations of these 6 objects. We have to find the number of arrangements of 6 objects, and we are considering 6 objects at a time. That is, we have to arrange these 6 objects out of 6 objects, and we know that this is nothing but 6 factorial divided by 6 minus 6, that is 0 factorial, and that turns out to be 6 factorial. And we can count this, that turns out to be 720 permutations. Therefore the number of permutations of the given letters which contain the string ABC are 720. So this is another interesting problem I have written systematically. Because the letters ABC must occur as a block, we can find the answer by finding the number of permutations of 6 objects, and one object is, we consider block ABC as one object, and the individual letters which are D, E, F, G, H, that is 5 letters. So total we have to consider 6 objects, one ABC as a block and these 5 letters. And we know that the 6 letters can occur in any order, and therefore there are 6 factorial, that is 720 permutations of the letters in which ABC occurs as a block. So in this way we can easily answer this type of problems. All we have to remember is that whenever order is important, if order matters, then the number of arrangements are nothing but number of permutations, and we have to use the formula for counting the number of permutations of n objects taken R at a time, and the formula is n into n minus 1, n minus 2 and so on, n minus R minus 1, or equivalent formula is n factorial divided by n minus R factorial. And we are considering arrangement of all the objects, then that turns out to be n factorial. So here we have 6 factorial, that is 6p6, and that turns out to be 720. So this is all about this session. I hope you like it. Thanks for watching.